Okay, so we're going to start section 7.7. These are applications of rational equations. So in the last video we were solving equations which contain fractions. And we're going to continue to do that here, although I think at least to start these fractions are going to be, these equations rather, are going to be a little bit easier. Okay, so the first thing we want to do is solve what are called proportions. Now, what is a proportion? Well, first we need to know what a ratio is. A ratio is just, ratio of A to B is just a fraction, A over B, right? So a proportion is just an equation in which both sides of the equation are just fractions, ratios. So, for example, A over B equals C over D. A over B equals C over D is a proportion. Okay? And, you know, we don't know exactly what we're gonna solve for yet, but just to give you some idea of how we can do something like this, so let's write A over B equals C over D, right? And if you remember, the first thing you want to do in solving an equation like this is to get rid of the fractions, right? To multiply both sides by the least common denominator. Okay? And so to do that, we would first find the least common denominator. In this case, there's only two denominators, B and D, right? So our LCD is just B times D. And we would multiply both sides by B times D. So here's the equation. Multiply the left side by BD over 1, right? And do the same thing to the right side, B times D over 1. So when you do that, notice what happens. On the left, the B's cancel, and on the right, the D's cancel. So you're left with the equation D times A equals C times B. Okay? And we get rid of the fractions. Now again, we don't know if we're solving for A or C or B, right? At this point, it doesn't matter just yet. But the point is we wanted to get rid of the fractions. So instead of doing all that, look at what we could have done here. Take the original equation and just multiply A times D, or D times A, right? Same thing, A times D. And that has to equal what you get when you multiply the other diagonal, B times C, or C times B, right? So most people call this cross-multiplying, right? You're multiplying across, right? In other words, diagonal here. So when you cross-multiply, right, you just get the equation you're looking for. You get rid of the fractions all in one step, right? So you could do it either way. Cross-multiplying is just a quick way of multiplying both sides by the LCD. Okay? So with that in mind, let's look at our first example. We want to solve this equation here, 12 over x equals 3 over 10. And we recognize this is a proportion. We have a fraction on the left. In fact, let me just copy it down. We have a fraction on the left side, 12 over x. And we have a fraction on the right side, 3 over 10. Okay? So if we want to solve this for x, right, we're solving for x, the easiest way to do that is to multiply the cross terms, right? 3 times x, and that has to equal 12 times 10. And of course, 12 times 10 is just 120. Right? And now, to solve for x, we just divide both sides by 3. 3 divided by 3 is 1, so we get x equals 120 divided by 3 is 40. And so that's the solution to this equation. Don't forget to check, right? It might be helpful to check. If we replace x with 40, we get 12 over 40. So the question is, does that equal 3 over 10? Well, it may not be obvious because it looks like they're different fractions, right? But remember that 12 over 40 is not in lowest terms, right? They both share a factor of 4, right? 12 is 4 times 3, and 40 is 4 times 10. So if you cancel the 4's, you're left with 3 over 10. So indeed, right? 3 over 10 does equal 12 over 40. So in other words, this is correct, right? And so that's how we know that x equals 40 is correct. So yeah, so I hope that helps. One thing to note, though, that we kind of skipped over here, in the last section, we also found the restricted values, right? And remember, x is in the denominator, so x equals 0 was a restricted value. So notice that x cannot be 0, but we didn't get 0 as our answer. So in this case, it was okay not to worry about that. Okay. So yeah, but in general, you should find the restricted values first. You should make a note that x equals 0 was a restricted value. It didn't matter in this problem here. So x equals 0 was a restricted value. And I would say in most of the problems in this section, it's not going to matter. Okay, so let's go on to the next example. 3a over a minus 6 equals 2 over 7. So here we want to solve for a. Right? Doesn't always have to be x, right? So let me just write down the equation again. 3a divided by a minus 6 is equal to 2 over 7. Okay, so this is also a proportion. This is, the left side here might be a little more complicated, but it's a single fraction. You have a numerator and you have a denominator, right? And the right side is a fraction too, right? So that's what makes it a proportion, right? So you can only cross multiply. I should emphasize it. You can only cross multiply, right, when you have a proportion. If you have something more complicated, like if you have a sum or difference, say, on the right, that's no longer a proportion, and then cross-multiplying just won't work. But for these problems, this is a proportion, and so we can cross-multiply. Let's multiply 3a times 7 on the left, and that has to equal 2 times a minus 6. A minus 6, right? Well, 3 times 7 times a, right? Remember, the order doesn't matter here. 3 times a times 7 is 3 times 7 times a. 3 times 7 is 21. So 21 times a. And on the right side, we have to distribute the 2. So 2 times a is 2a. And then plus 2 times negative 6 is negative 12. Okay, so we get an equation in a. And we know how to solve that, right? You want to, since it's a linear equation, there's no a squared here. You want to isolate the a, so we can subtract 2a from both sides. And when we do that, we get 19a on the left equals, right? So 2a minus 2a is 0, but we still have negative 12. Right? And finally, to solve for a, that's an a, sorry, divide both sides by the 19, right? So divide both sides by 19, and then that gives us our answer. A has to be negative 12 over 19, rather. Right. And it doesn't matter whether you leave the negative in the numerator or the denominator. I tend to put it in front. So it's a negative fraction, right? It's a negative divided by positive, which is negative. Oh, 12 over 19 is irreducible, right? It's already simplified. It's in lowest terms because 19 is a prime number, so there's no way to simplify this any further, right? Okay, so let's go on to another example. Scroll down here. Well, okay, we'll do one at a time though. Example 3, this is going to be x minus 2. So x minus 2 over 3x minus 2 equals 1 over 4. Okay. Now notice that we have in the denominator, well, I guess we should have mentioned that in the last problem. A equals 6 would have been restricted value here. So what makes the denominator 0 here? A minus 6. So when you add 6 to both sides, a equals 6 was a restricted value. On the other hand, we didn't get 6 as our answer, so not an issue. Likewise here, we technically should find the restricted value. 3x minus 2 equals 0 gives us x equals 2/3. And that's our restricted value here. But, I don't think that's going to matter here. All right. So now what do? Cross multiply, right? We have a fraction on the left and a fraction on the right. So this is going to be 4 times x minus 2 on the left, and that's going to equal 1 times 3x minus 2 on the right. Again, 1 times 3x minus 2 is just 3x minus 2. And then distribute the 4, right? 4 times x minus 4 times 8. Okay, well, it looks like we can, again, this is not quadratic, right? There's no x squared, so we can just isolate the x. I would subtract 3x from both sides, and that gives us 4x minus 3x is just x, minus 8 equals negative 2. Okay, now just add the 8 to both sides, plus 8, plus 8. And so x equals 8 minus 2 is 6. And I think that's it. So, yep, again, you can always check if you plug in x equals 6. Oh, let's do that. We forgot to check here. It's a little more complicated with the fraction, but you should check regardless. Or at the very least, plug it in the calculator and see if both sides are equal. Right. So let's check. If we plug in x equals 6 here, we get 6 minus 2 over 3 times 6 minus 4 equal, or does that equal 1/4? Right. All right, so we know what the right side is. It's just 1/4. Let's look at the left side more carefully. 6 minus 2 is 4. 3 times 6 is 18, and 18 minus 4 is 14. And 4 over 14 reduces to 2 over 7, which is not 1/4. Okay, so obviously something's wrong here, right? So I must have done something wrong, because when we plugged in 6, I don't think that works. 3 times 6. Oh, I'm sorry, it's 3 times 6 minus 2. That's a 2. Ah, well, there's my problem. I didn't copy the problem down correctly. So, okay, easy fix. So 3 times 6 minus 2. So this was 4. 6 minus 2 is 4. That was correct. But this is 18 minus 2, which is 16. 18 minus 2 is 16. And that reduces to, right, this is 4 times 1 over 4 times 4. Cancel the 4s. This is indeed 1 over 4. So, okay, so it does work. It is correct. Yeah, so when you check, of course, you got to be careful. Copy the problem down right. I replaced the negative 2 with the negative 4, and, well, I was almost doubting that I did this correctly, but this actually works. This is correct. What was incorrect was, well, this part here, I copied it down wrong. Okay. So, yeah, we all make mistakes, right? I'm lucky that I actually spotted my little mistake here, and I was able to fix that. Okay, let's do another one. So we have a 12-ounce can of soda, has 150 calories. The question is, how many calories are in a 20-ounce bottle of soda? So, okay, so we have 12 ounces. 12 ounces. That's a standard aluminum can of soda, right? And this happens to have 150 calories, right? Well, now we want to know how many calories are in a 20-ounce bottle. So if we have 20 ounces, the question is how many calories, right? So instead of a question mark, let's use the mathematical symbol for the unknown. That's just x. So x calories, right? So in 12 ounces, we have 150 calories. How many calories are in 20 ounces, right? And if you notice, just the fact that, right, the ounces and calories are the same in both, this is actually just a proportion. We have 12 over 150 equals 20 over x, right? So this is a proportion, and if we solve for x, that should tell us the answer. So this is not unlike the very first example we did. It's a very similar format here. So again, the easiest way to solve this, I think, is to just cross multiply. So 12 times x equals 20 times 150, which I think is 3,000, right? So now divide both sides by 12, and so 3,000 divided by 12, feel free to use your calculator here, is 250. Right. So that's our x, right? X should be 250. 250 what? 250 calories, right? How many calories are there in a 20-ounce bottle? So the answer here is 250 calories. Okay, so let's do one more sort of word problem here. So I know this might be a little small, so let me read it carefully. In a recent survey, 9 out of 46 people claimed that they subscribed to Spotify. At that rate, how many people in a town of 6,500 people subscribe to Spotify, right? So 9 out of 46 people. That's a ratio. We have 9 people subscribe. So 9 subscribers, if you will, right? And out of a total, the number of people surveyed was 46 people. So 46 people, only 9 of them subscribed to Spotify. So now the question is, how many people subscribe to Spotify? So how many subscribers? So we'll call that X. How many subscribers when we have a town of 6,500 people? Okay. So again, we have our proportion, right? So this is just, I'll write it under here, 9 over 46 is equal to X over 6,500. Right? And not unlike the previous problem, we just cross multiply, right? So this is X times 46, or 46 times X, equals 9 times 6,500. Okay. So 9 times 6,500, my calculator says 58,500. And that's still equal to 46 times X. So now we divide both sides by 46. Right? The opposite of multiplying by 46 is dividing, right? So divide both sides by 46. So X equals 58,500 divided by 46. So now when I plug that into my calculator, it says 1,271.73913 and so on. Well, think about what we're doing here, right? We're looking for the number of people in a town of 6,500 that we expect, based on this survey, to subscribe to Spotify. So how many people would we expect, right? If we have the same rate here, how many people would we expect to be subscribers, Spotify subscribers, in a town of 6,500 people? Right? And the answer should be 1,271, or if you round up, 1,272 subscribers. Okay. After all, 0.7 people, I don't know how you get, a fraction of a person, right? So you would either round up or down. The 0.7 indicates we should round this up. But at this stage, if you round up or down, I don't think I'm going to be picky about that at all. So if you had 1,271 people, that's close enough. We're not going to haggle over 1 or 2 people here. After all, we could be way off. There might only be 900 people, or there might be more than this, right? But this is what we expect based on this survey. Okay, so that's the idea here, right? You just translate the words into these equations, and then when you solve the equation, you should get your answer. And again, I think I already mentioned either one is correct here. You know, if you're off by 1 or 2 people, it's not a big deal.